Welcome everyone to yet another Business Central office hour call. This call is going to be the last call of this calendar year. So really pleased that you are all joining us. We actually have more than 500 attendees that have signed up and registered for this call today. And we also have a very hot topic. It is namely going to be troubleshooting performance problems that we will talk about today. And we have Christian Heidedam, Kenny Pontoppidan, Kalman Beres, and Jens Müller Petersen to help answer all your questions. And Christian Heidedam will take us through first a couple of things around the topic, and then we will open up for questions. We would love to use time on all your questions, so do make sure questions that you would like to ask on this topic during today. Feel free to write these questions in the Q&A panel during the presentation, and then we will take all your questions towards the end of the call. With this, I want to hand it up to Christian to take us through the topic.
Thank you, Lotte. Yeah, welcome everyone. My name is Christian, and I'm going to take you through a number of our most useful tools for troubleshooting performance problems. There will be a little bit of presentation and a lot of demos, and then there will be time for Q&A at the end. And I also would like to hear your feedback if you can see things that we can improve, have ideas for things we can do to make troubleshooting even easier. So let me start with this simple drawing to show where performance problems typically come from. So we have users using a browser to connect to Business Central. We have a compute tier. This is where your AL code runs. And we have a database tier. So obviously the very common way to introduce the performance problems is in your AL code. If you have an AL code performance problem, how do you deal with it? The best tool that I know of is the Incline Performance Profiler. It's a page, as you can see in the product, and I'll show you in a moment how it works. Actually, I'll jump right to my first demo. So now I'm in Business Central, and I have installed a PTE, my little PTE in this environment, and it allows me to demonstrate a number of performance problems and thereby also allow me to demonstrate how to troubleshoot them. So the first one is, let's say I have a very simple scenario of some AL code that runs slow. Let me run this. It should take approximately 4 seconds. Or 7 seconds, sorry, 7.3 seconds, 4 seconds. And the question is, how do you deal with a situation like this where that's a bit too slow? How do you troubleshoot it? Well, as I said, the best tool, the tool you should always start with is the Incline Performance Profiler. You access it from the help and support page here. And you can then click Analyze Performance, and it's going to open up the Performance Profiler. So now we have 2 windows. I'm just going to dock them next to each other so we can see both at the same time. Like this. And so these 2 windows are now connected to the same session. So when I start this, actually I'll just start it now. What it's doing now is it's listening to everything that's going on over in this window. So let me run my scenario again. And it should take the same amount of time, 7.3 seconds maybe. Done. And I can stop the performance profiler. And what it will immediately tell me is that there was only one active app. I'll get back to what active apps means. And the active app is Troubleshooting Performance Demos, which is my PTE. And it was active for 7 seconds, a little bit more, which matches this pretty well. It's not accurate. I'll also explain why it's not 100% accurate. So if you click Show Technical Information, you can see more detail. There's also a concept of time spent, which is different from active apps. But in this case, it's the same. because there's only one app involved. And that's my app, my PTE, and it was spending all of the 7 seconds. I can also see which application objects were involved here and how long time each spent. There was only one object, it was a code unit, and it spent the whole time. It came from my PTE. Finally, there's a call tree at the bottom where I can drill in the call stacks, and I can see, let me just make this a little bit bigger. I can see that the whole thing took 7 seconds. And if I drill further down, I can start to see that there was something called update settings that took 5 seconds. 1.1 seconds of that was spent directly in update settings. The remaining, what is that, roughly 4 seconds, was spent somewhere else, not in update settings itself. So if we drill down further, we can see that those 4 seconds were spent in a method called save all. Save all is also present on this level where it took 2 seconds. So just to show you the code behind this, let me switch to VS Code. So here I have my simple scenario. I call update settings 4 times and save all 2 times. And update settings itself, it sleeps for 300 milliseconds, and then it also calls save all. So update settings is called 4 times. 4 times 300, that's 1.2 seconds. So that's this number you see here. And then in total, it calls save all 6 times, and each time it sleeps a second. So that's 6 seconds plus the 1.2 seconds, that's the 7.23 seconds. So you see the save all here is called 4 times in the context of update settings and 2 times directly making this the 2 seconds. That's a very simple scenario. You can see it allows me to drill down and see where the time is spent immediately. Let me run another scenario here. So I'm going to clear the profiler again and start it again. And let me run a slightly more complicated scenario where we have more than one app involved. So this took 1.3 seconds. Let's stop the profiler. And we can see here that there were 2 active apps now. One is mine. It took 1.2 seconds, or it was active 1.2 seconds of the time. And the base app was active 900 milliseconds of the time. Okay. Then we have in time spent section, we can see that, let me make this a little bit bigger again. We can see that the base application was spending most of the time here. So you see there might be a correlation between these 2 graphs, but there isn't necessarily. This one is my PT is biggest up here, but smallest down here. These are 2 different perspectives on who is using or causing performance problems. And if we drill down in the call tree, we can see that the whole thing starts in my PTE, and the whole thing takes 1.2 seconds. And then it calls some methods in my PTE until finally it calls into the base application. And then you can drill down and see where in the base application things are taking time. So at this point, I think I would like to describe the difference between active apps and time spent. And there's a little text here that shows it for those of you who read documentation. But I have a little slide that also demonstrates the difference. So an active app is an app that is on the call stack. So there can be more than one app on the call stack at the same time. Time spent is the code that is running, that is actively running. So it means basically at the top of the call stack at any time, at any point in time. If we look at this PTE code that I've created, you can see there's a loop from 1 to 10. Each time it sleeps 500 milliseconds, and then it calls into base app to post a sales order. And just for the sake of this calculation, let's imagine that this always takes 1,000 milliseconds. and it all takes place inside the base app. So we'll look at how long time this will take in total. It's 500 milliseconds plus 1000 milliseconds, 1500 milliseconds times 10, that's 15,000 milliseconds. But let's look at the two concepts, time spent versus time active, and our two apps. So those two dimensions gives a 2x2 matrix here. And let's look at how long time was spent in the base app. And spent in the base app, we can see we ran base app code for 1000 milliseconds times 10, so that would be 10,000 milliseconds. How much time was spent in my PTE, meaning how much time was it executing its own code? Well, it was this code only, 500 milliseconds times 10, that's 5,000 milliseconds. How long time was the base app active, meaning on the call stack? Well, that was all the time that we were in the post sales order method somewhere or deeper. And that was 1,000 milliseconds times 10, so also 10,000 milliseconds. And how long time was my PTE active, meaning how long time was it on the call stack? Yeah, it was on the call stack the whole time, right? So it's all of the 15,000 milliseconds. So I hope this conveys clearly the difference between time spent and time active. So if we go back here, as the text also says here, the duration here represents the time you might save by removing an app. Of course, if you remove an app, you also lose functionality. So it's not always a solution to just remove an app, but it gives you this, let's say you install an app and suddenly things are slower. You go in here and you can see that, that app is responsible for, is active a large percentage of the time, let's say several seconds. Then without actually uninstalling it, if you were to uninstall it, you would save those many seconds. So the way the profiler works here is that it, as the scenario runs, every 100 milliseconds, it kind of pauses the process and looks at what is on the call stack. Anything on the call stack, that's an active app. The top of the call stack, the one that is currently executing, that is the one that is spending time. And then after it releases the process again, and 100 milliseconds later, it stops it again just for a brief moment and looks at the same. And that's also explains why these numbers are not accurate, because in between 2 points of the 100 milliseconds, it doesn't actually know what's going on. It doesn't look at that. It only looks at those snapshots, those points in time. So sometimes if I run it again, I can try in a moment to run it again, a similar scenario. And then we might actually also see the system application in here. But let me run another scenario. I'll clear this one again, and I'll start the profiler again. And this time I'm going to run the subscribe to base app scenario. It's doing more or less the same, namely posting a sales order. So it took 6 seconds. Who was active? Let's make this a little bit bigger again. Okay, so my app was active most of the time. That is not surprising because it was my button that was clicked here. So of course my app is on top of the call stack or the bottom of the call stack. So everything we do from there on, my app will be on the call stack. But base app was actually the most, also very, very active. So it was also on the call stack. So just by looking at this, we would say if you uninstall the base app, we would save 5.6 seconds. But that's not a solution, as you can imagine. So if we look at the time spent, we can see that, interestingly, the base app is pretty fast, but it's my app again that is spending a lot of time. And if we drill down in the call tree, we can see what's going on. We can zoom in. As long as we see a lot of time here, we know we are on the right track. On run. And on after post sales doc, and there you see I have set up a subscriber to when a sales order is posted. So if you consider who this tool is useful for, of course you can use it as a partner, but I would also claim that a customer can use it. If we uncheck this again, any customer, I would say, or I don't know if any, but most customers can probably launch it, click start, reproduce press the button that is slow, for example, and then stop, and then see this picture, and they can already see, what app was causing it. But maybe they are not the best people to analyze it deeply. But what they can then do is download the profile here. So it's downloaded it, and I have it here. I'm just gonna copy the path and open it in VS Code. Okay, so I'm back in VS Code, and I'm gonna open the file. And then you can see, if I open this again, and see the call tree here, you can see similar, or actually almost identical structure over here. So you can imagine that your customer sends this file to you. You are the one who is drilling down here and saying, I'm looking for where this time is spent. It's on after post sales stock. What is going on there? And then you see it, right? You see it is this event subscriber that is causing it. Now you know how to fix it. What you can also do in here, by the way, is navigate. So if you have the source code, or you can download the source code even for the base app, you can just click any line. Let's say I want to see finalized posting. So now it just downloaded, and you can see the source code. Maybe that gives you a clue as to what is slow. So this is if you have AL code that is slow. You can see in the profiler where the time is spent pretty quickly. But let's face it, most often it's not AL code in isolation that's slow. It's mainly when it calls the database. And we have a number of common patterns that cause slowness involving the database. The first one is logging. So here you have a session that takes a log on a record, for example. And then another session would also like to take a log on the same record, but it can't. So it has to wait, meaning it is slow. Another scenario is long-running queries. This is typically when you have a lot of data and you're missing indexes on your table for the query that you're making. And finally, we have many short queries, which typically also if you have a lot of data and you are iterating over something. So even if each query takes only a millisecond, if you have thousands of them, then it adds up. So how do you troubleshoot these cases? I'm going to show you. Okay, so I'm back in Business Central. Just for fun, I'm gonna keep the profiler open here. And then I'm gonna do one of the scenarios. Let's say I wanna do long-running queries. I've already created some sample data that, I need a lot of data to make queries slow. So I've done that ahead of time. So I'm gonna run the scenario now. So that took 3.4 seconds. Let's see what's in the profile over here. Yeah, we can see it took that much time, and we can also drill down and see where in the code it was, but there's actually no drill down here because we can see it all took place in the same method, namely the onAction trigger on the page, on an action. So this doesn't tell us the details of what went on. We can of course go here and look at the source code and see it's probably doing something with the database, but we can't see it directly here. But what we can actually is look at telemetry, because whenever a query takes more than 750 milliseconds, we emit an event to your App Insights. If you haven't done so already, I really encourage you to go to the admin center, go to your environment, and then configure your application insights connection string, which if you do this, we will send events to you when things are happening here that are relevant. So let's go and look at my App Insights account. So this is the one that I configured on the admin center. And let's take the top highest timestamps, meaning the most recent ones. And we can see there is one just a moment ago where it says operation exceeded time threshold, and it's a SQL query. It can also be an AL method. And we can see here that the statement was a delete statement. The threshold, as I said, is 750 milliseconds, but it took 3.4 seconds to execute this, which matches pretty well with this. And we can also see where in the code it took place. It was in this onAction trigger. So with this information, you are probably able to figure out how to delete, but how to fix a problem. So any SQL statement that takes more than 750 milliseconds will show up here. I'm going to close the profiler now because we're not going to need it anymore for this session. Let's take the next scenario, many short running queries. So here we have just a lot of queries, and the whole thing takes 7.5 milliseconds. We can go and look in telemetry, even though the telemetry is taking a couple of minutes to reach application insights here. It's not there yet. It's not gonna come actually, because each of these queries was quicker than 750 milliseconds, and we're not emitting them to application insights because there would just be too many events emitted. But there is a way to get it there. If you have a suspicion that it's because we are making many SQL calls, you can go again to the help and support page, and then you can turn on additional logging. And it will be on for the next 15 minutes. So anything I do now that involves SQL statements, every single SQL statement will be logged to application insights. So I'm going to run it again now. And what was it, 7.5 seconds, something like that. 8 seconds this time. And let's go back to application insights and look at the most recent events. So it still hasn't come yet, but I bet it's going to come real soon. Yeah, there you go. So if we look here, we just take the last 1,000 events, they will all be SQL statements that were executed. And if you look at the timestamps, they are very close to each other, right? So they just come, it's rapid fire. Each one, you can see in the custom dimensions here, you can see where it was in the code. There was again a trigger. And you can see that the SQL statement here was inserting a record into a table. And this one took 1 millisecond, right? But there were just many of them, so it ended up taking 8 seconds. So this is a very nice way to troubleshoot things if you have a suspicion that it's because we're making many database calls. You can turn on the additional logging, and then you can use application insights to see if it's actually the case. So additional logging is turned on in this session. I'm going to create a new session by creating a new tab. So this session does not have additional logging turned on. So which is what I want. I'm just going to close this other one. The final typical case, as I mentioned, for performance problems involving the database is logging. So I have an action here, execute. It's going to take a log on a record, and then it's going to release it again really quick. And it's finished. immediately. And the thing with logging is problems typically manifest themselves when multiple users are working at the same time, because then they step on each other's toes, so to speak. So to demonstrate this, I'm also going to create a simulate having multiple users active at the same time. So here I have 2 sessions, and if I can run this quick one in both, and does the same thing. But if I say, let me run something that takes a log and then keeps it for 15 seconds, and then quickly go over here and also do maybe just the quick one, you can see both of them are hanging now. I get the spinning wheel. At some point, this 15 seconds over here will pass. It will release the log, at which point this one will be able to take the log and it releases it quickly. So how do you troubleshoot something like this? Of course, this one, the person who is working over here, he might say it's okay. It takes 15 seconds because he was running a report or something, and it's expected that it takes 15 seconds. But what he doesn't realize is he's logging it, some tables the whole time, which is preventing others from doing quick things. And that's not acceptable. So how do we troubleshoot this? I'm going to open yet another window, because I want to have 2 windows that are reproducing the scenario, and then I want a 3rd window where I can see what's going on. So let me just dock these like this. And over here, I'm going to open the database logs page, which is a built-in page in the product. And what this page does is ask the database. It asks SQL Server which logs exist right now, and also who's waiting for a log. And if I press F5, you cannot see that, but I'm pressing F5 multiple times now. It's going to ask SQL Server again and again and again, and I can see what's going on in terms of logging in the database. So if I repeat the scenario here and start the slow thing here with 15 seconds, and then immediately I do the quick one here, and then I go over here and press F5, I immediately see one has the log, another one is waiting. The log is on this example logging table, and I can see more details. I can also see the session ID, which and I can also see who's logged in. In this case, it's the same user, but you could imagine 2 different users. One has the log, another one is blocked from working because he's waiting for the same log. And I can also see on which page it was and what was executing at the moment. So you see these are the methods that we're executing. So let me try that again, and this time I'm going to run the 15 seconds on both. So now both are spinning here. F5 over here, one has it. If you remember, the 952 one has it. At some point it's going to finish over here. Now it finished. So now it's gone. It's no longer logging or waiting for a log. And now the other one got the log. So if the user down here is complaining that it's waiting, it's very slow, you can go in here and see, yes, indeed, that user is waiting for a log, and you can also see who has the log, and maybe you then can figure out what the problem is. The final scenario I want to show you here around logging is if you have something that is waiting for a long time to get a log, it will actually time out. So here there's a difference between 15 and 40 because we have a threshold somewhere of 30 seconds that I'll demonstrate now. So I'm gonna run this and it logs for 40 seconds. And then I'm gonna, doesn't really matter, I'll just pick this one, 15 seconds. So this one has the log now. This one is waiting for a log. Now the one that has the log, it can keep the log for hours if it wants to, if it has a large job. Not a problem. But the one that is waiting for a log is gonna give up after 30 seconds. So this one at some point very soon is going to say, I have waited for 30 seconds on this log. I'm not going to wait anymore. There you go. And then now the 40 seconds passed. So now it could have gotten the log, but it stopped waiting. So the way to troubleshoot this is a very severe logging problem, right? Because you have to wait up to 30 seconds or more than 30 seconds for this to kick in. This is more than the average wait time for a log. So how to deal with this situation? The detailed help actually tells you how to troubleshoot. Either use the database logs page, which we used before, or use telemetry. So in this case, when you have a log timeout, we log it to telemetry as well. And how to find it in telemetry? Search for this string 2A91234. Remember that. And let's go to our App Insights account here. Let's take the last 100 records. And so now we have an option. Either we wait a few minutes, or I show you something from earlier today. I'm going to show you something from earlier today. So this was earlier this morning. So you see here, it emitted a log timeout. This was the victim. The victim timed out. And we can see the victim, what were they doing? They were in this call stack. They were trying to do something that logs for 15 seconds, if you remember. And what they were doing is they were selecting a record. Okay. Now they timed out. Who had a log at that point? Well, we take a snapshot. This is a different GUID because this was from earlier this morning, but this GUID was the same that was shown in the dialog before. So here's a snapshot, and we get an entry for each line. So figuratively speaking, if you were to write at the moment where the victim got the log timeout, went into this page and press F5, then each line here would become one snapshot entry here. So here we can see who held logs at this point. Who are the guilty ones? And we can see here that it was somebody who was running this code. And what were they doing? They had a log on this table, right? So you can see the cause of the log timeout. And I have some slides showing what I just demoed to you. So if you're looking at the slides afterwards, you can see that easily here. So in the App Insights, we have the victim side, the database log timeout, and we have they were just doing something that was not supposed to take very long. And we have also these snapshot entries. And here we can see that there was somebody who had a log on this table. So if the victim was trying to access the same table, most likely it failed because of this log. And then for slow or mini queries, App Insights has these entries where you can see how long time queries took, what the queries were, and where in the code they executed. And the only thing is, if you are looking for short queries, you have to enable additional logging first. Otherwise, they will not appear in App Insights. And what I didn't show you is there's also a page called Database Missing Indexes. If you have a long-running query, it is very likely because you are missing an index. So I can also demonstrate that to you in the product. Database Missing Indexes. And in my environment, there are no entries here. What this page does is call as a SQL and ask, do you have any recommendations for indexes that I should add? And what as a SQL does is, over time, it looks at what queries are you making to the database. And then it is making thought experiments and saying, what if I added this index? Would it make things better or would it make things worse? There's always a pro and con of adding an index. An index needs to be maintained. That's negative, but it speeds up queries. That's positive. So it's making these, hypothetical logs. It's adding these indexes hypothetically, and then it's saying, I think actually it would be a good idea to have this index. And when it makes such a recommendation, and you go on this page, you will see lines here. I have no lines here because my environment is not very busy and I haven't added any extensions to it really. So, and also it takes time, weeks probably for SSQL to make these recommendations. But I have seen customer environments that I cannot share here, of course, where there were so many rows here. So this can be a gold mine of information. So we have those two. They have been accountable for 90% of all performance issues, I would say, those types of patterns. A new pattern has become more and more prevalent, and that is when EL code makes outgoing HTTP calls. And those are also easy to troubleshoot. So let me switch back to my environment here, and I'm just gonna run this, find my PTE page again here, and then I'm gonna make an HTTP call. My EL code is going to make an HTTP call to a web service, and I've designed this web service to be slow. So it took 10 seconds. And if we go, the way to troubleshoot this kind of thing is to go to Application Insights. And if I take the last records here, it's not going to be there because, again, it takes a couple of minutes for Application Insights to get it. But I have some traces from earlier this morning. And there you see, this is the entry that this one is going to give us eventually. And you can see here that it took 11 seconds when I did it this morning. And you can see the URL that it called. So if you see this and it's taking a long time, you have an explanation for why it's slow. Just last week, I was troubleshooting a case where a customer was claiming that their role center was slow. And when I looked at it, they made somewhere between 5 and 10 HTTP calls whenever the role center was opened. And that added up to almost 10 seconds. So that was the reason for that. And that's the demos. And I just have one slide here with an overview of the tools. So as I said, the Incline Performance Profiler is the best tool to start with. Always start with that. It tells you immediately what apps are spending the time. It makes this, if you were to uninstall an app, how much faster would it become? You can also drill down to see objects or even call stacks where the time is spent. And the best part is the customer can run this. It's so easy to use. And then they can send the result to you so you can analyze it. If you have certain various suspicions, for example, you suspect it's database logging, you can use the database logs page. And in very severe cases, namely when a client session times out waiting for a log, you can also see it in App Insights. If you suspect it's because of long-running queries, also you can go to App Insights because it will have a row for every query that took more than 750 milliseconds. And you can also open the database missing indexes page to see if there are missing indexes. That can also explain why it was slow, and maybe then you can solve it. If you suspect that it's many short-running queries, you can enable additional logging, and then App Insights will have all the telemetry you need. And finally, if you suspect it's because of outgoing HTTP calls, also App Insights is the tool that will tell you what's going on. So the best tool is the to start with is the incline performance profiler, and then you have suspicions that makes you, you can go around and check various things. This is very, very effective in my experience. But you also have to go around and check things. And one of the things we are considering is to make it easier for you by incorporating some of this into the performance profiler. So for example, you can imagine that in the call tree, we can see not only how long time a method took, but also that it made some database calls and how long time they took. So therefore, you don't have to go around and look for things. You can see immediately that it was because of a SQL query. And with that, let's go to Q&A. And I have my trusted colleagues with me to help answer all your questions.
Thank you, Christian. That was a nice deep dive you gave there, and maybe we should give you a little quick break. So we have both Kalman and Jens and Kenny ready here to help answer some of the really nice questions we've already gotten into the chat. So let's dive quickly into it. And the first question is a question that goes, the sampling rate of 100 milliseconds is quite high, and quite a lot of details, especially with the situation with a high hit ratio, might well get lost. Any plans of making it editable, already useful when possible, if only in sandboxes? Kalman, do you want to do a quick answer to that one?
Yes, so this scenario is currently only available on-prem. There is the sampling interval that can be specified. We don't have yet any plans to open this on SaaS, mostly because we want to control when an NSTB, when a client becomes a noisy neighbor. So with making this 0, I mean, yeah, we have to think about it. So it's not so trivial to make this. But there is an option. You can always do a snapshot debugging for the same scenario from VS Code. I know that's a little bit more complicated, but you can achieve instrumentation that way. So that's it.
Thank you. Good feedback. Next, we'll go to the next question.
Then I will just read that now. As an ISV, I would like to see the long-running SQL queries and deadlocks be added to ISV telemetry. ISV telemetry is when you add a connection string to application insights in your app.json file. The question or the answer for that is long-running SQL query telemetry is available in ISV telemetry. If not, that's a bug that you should log a bug for that. I'm not aware that it shouldn't. Whereas deadlock telemetry is not. The reason why we don't log deadlock telemetry to ISV telemetry is that we log signal of the victim of a deadlock, and the cause of that deadlock could be anywhere. It might not be in the context of the app code in the extension. So that's why deadlocks are not available in ISV telemetry. Over to you, Jens.
The next. Slow-running AL methods in telemetry are mostly run models of pages and such. I've heard a rumor that those will be filtered out so that the real slow-running AL methods will be reported. Is this true? So we are aware of this limitation, and it is on our radar to change it, but currently it's not on top of the list. So no promises on ETA.
Right, next question is, I'm just trying to answer questions and reading out loud. Let's see here. How do you enable get setup application performance inside or telemetry? So that is a good question, and hopefully the answer is also good. So you can go to the URL that I put in the chat. It points you to the documentation of telemetry. The short URL is aka.ms/bc telemetry. And there it takes you through the setup of telemetry and all the different ways you can use telemetry, including installing Power BI apps, alerting, how to control costs and everything you probably need to know.
Yes, and then there is a question about, is there a plan to add a blog log history? It will be very useful. So currently we have the two signals on database log timed out and database log snapshot. We may improve on these in the future, but as Kenny alluded to, this is in the environment telemetry, and we are looking at how we can make them even more useful.
Right, let's see, next question is, why is there a service tiers option to disable the SQL query hint optimized for unknown since version 18 in Business Central Server? That is simply because we want to remove the usage of optimized for unknown in the product. And this is kind of the version where we started turning this off. You can turn it on again if you want. Now, the naming of this option is confusing, and we have debated that. So what does it mean, true, false, if you have something that says disable something enabled? And we're sorry for that. But hopefully after a few reading through that, you will know what true or false means. But eventually this is going away in Business Central using optimized for unknown. Let me just take the next question while I'm at it. There is this database missing indexes. Is that based on Azure database tuning? I answered that this is based on query stored data. I'm not actually sure. I added the documentation for missing indexes in Business Central in the chat, so you can go read that. We do read from two different what we call DMVs, dynamic management views on the database, depending on whether you run Business Central on Azure SQL or run it on SQL Server. It's two different views, but that's where we read the data with the missing indexes and present that on this page.
Yep, then there is a question about OData performance for creating 1,000 sales orders via web service. To rephrase it, what to expect with performance online versus on-premise. And the answer is, in general, you should not see a large difference, but of course it depends. If you have a lot of SQL calls, meaning that the underlying API page, hopefully you're using API pages instead of UI pages. If that has a lot of SQL calls, then you may see larger latency between NST and SQL, because we can never beat having SQL and NST co-located on the same box. But in general, you should expect about the same. For large data retrievals where we need to have, where we put in reply URLs, we do know that we have a small overhead, up to 10%, but we expect to be able to remove that. But in general, you should expect approximately the same performance for the on-premise versus the online.
Yes, and I had a question about whether missing indexes was only available in the online version. No, the missing indexes page is available both for on-premises and for in the online version. And here on-premises mean non-SaaS, and it's available both for if you're running the database on Azure SQL or if you're running on SQL Server.
Kalman is typing something about the modal page. Kalman, do you want to read it aloud and talk about it?
Well, so, modal pages, so if they appear or they don't appear, I mean, in my opinion, you can stop the performance profiler. That time modal dialog being up doesn't count for the sampling profiler. It's taken out from the measurement. So I mean, you can anyway. Okay, you mean you should be able to stop it, in my opinion. So and see what led to not being opened. Yeah. So that's a sort of a half answer, but that's my answer.
Then there is well, more of an observation more than a question. The index of frequently used list pages are the primary key, not the way that users use the pages, nor do they support default page filters. It would be beneficial to see the base index in the base list pages updated. Now, I assume that what the question is about is the default sort order, because the index is on the table where the primary key will still be the primary key. We're not changing that, but thanks for the feedback about the default sorting order on list pages.
And I have a similar question about indexes. Base app has disabled indexes, but what's the benefit of this? Why are they're not being enabled? So basically the question is, why do you have defined indexes on the base app that is disabled? It is actually on our roadmap, as I write in the answer here, that we want eventually for partners to be able to turn indexes on and off on an environment. We don't have any ETA for that, but that's something we want. It's actually the last building block in our story for index maintenance or index tuning for partners. And the next question is similar. Is there a possibility to see from BC which missing index has the highest impact? This is also a similar thing on the roadmap. So we will actually bundle the ability to turn indexes on and off with the ability to see the impact of indexes. Like if you have indexes that are not being used, you could consider turning them off. Of course, you might be burned end of month, end of year, because that's what is really needed. But with great power comes great responsibility, I guess. Yeah.
Yeah, and then there's a question about when a user is logged by another user, they want to know who the other user is. Is it possible to add the name to the message? So this is not it's currently not possible. It is something that we are consider if we can add that. Some of the problems with that is across NSTs, etc. And then of course also what rights would it require in order to see the names of the ones logging? So it'll take some figuring out how that should actually work. So don't hold your breath right now.
We have a question here about outgoing web service requests. That's telemetry RT0019. I'm sure Lotte is happy about knowing that. Please add stack trace to the telemetry. This would be useful for debugging. I'll add that to a list of small improvements that Jens and I have in our backlog. And I don't have any ETA for that, but yeah.
Yeah, I can take the next one. Do we have a demo project, the one that I use for demonstrating, and that's not available, but I have something that is just as good, actually better, and that is on BC Tech. We have an app that you can install, and it contains a number of performance problems. For example, in the Quiet Widow challenge, it makes a similar slow call here. So it has the same scenarios basically, and it also has more because it also has problems for permissions and the debugger and data problems. So not only performance related problems.
Jens, do you want to take the log generated outside?
Yes, so if a log is generated from outside BC, any external tool, are we able to see it also in the database logs page? And I must admit, I would have to double check. Of course, this is not relevant for SaaS, where it's only the NST that can talk to the database for on-premise. Since it is built on top of the dynamic management view, there is nothing keeping us from doing it. I don't know if we have actually filtered the ones away where we don't have an AL session. But of course, you won't see any AL information. But we'll have to double check, but there's nothing particularly problematic in being able to see that. But I don't know the answer off the top of my head.
I was reading the source code like 6 months ago, but I can't remember what we joined to. But yeah. Lotte, there's a question for you.
Yes, exactly.
Do we have
do we have the session recorded? And yes, we in a few days, we will make the full recording available for you, and I am just pasting in the link, but it is aka.ms/BC office hour recordings. But I'll put it in now.
That's that. Let's see. There's a question or comment, maybe. Adding missing indexes does not improve performance if the original source code does not make use of the index. Well, it's not really the AL source code that will make use of the index. It will be the generated SQL coming from the platform. So if SQL is suggesting an index like that, it's likely that the platform has created any SQL statement that would have liked the index. But of course, we can never be sure. It's just a suggestion. Then there's a question for you, Kalman, how to profile a background session.
Yes, you can do it today. Well, with from VS Code, if you start a snapshot debugging session on a background client type, and then you know, snapshot debugging will always you can generate a profile out of a snapshot file. Actually, a more detailed one than sampling one. It's based on instrumentation, so you can do it that way.
And there's a question in our basic testing of the standard sales posting on on-prem versus online. Online seems to beat on-prem by a factor of 10 or so. Is this normal expected? Now, it doesn't really state whether this is through OData or through the client, but no, in general, this should not be the expected difference. But I do not know the setup, what we are comparing here, so it's really hard to judge.
Yeah. Last question.
Yeah.
Is it looks like a suggestion about when we do the SQL generation from query objects, not to wrap tested fields in is null. Let's take a look at that, Jens, to see if we have something to improve. We are actually investing in queries and query objects over the next releases anyway, so it might be something we could put there.
Thank you for all your questions, and with that, we will round off this call. Christian, can I get you to just advance the slides? So we had a lot of questions in the call today, but please remember, if you have questions for us in general, do use the Business Central Yammer group for partners. You can see the link here. There's a lot of subgroups where you can post specific and relevant questions to a topic. Make sure to join the conversation in general on our Twitter account. As always, if you are looking for some relevant link or resource for Business Central, we are collecting all of the most important resources and links on the page that's called aka.ms/bco. As always, remember to submit ideas for future enhancements or features of the product on BC Ideas. And if you didn't get to watch this call, or you want to re-watch it, or any other call, then you can, oh, sorry, that was not the correct thing. If you didn't get to watch any of the sessions from the latest Business Central launch event, they are still available at BCLE. You can see the link here. A lot of specific sessions on what we released in the Business Central launch event in the latest release. And then for the next call, next slide, January 17th, we are going to have the next office hour call. And the topic is going to be exporting your Business Central data to the Azure Data Lake storage. And then finally, if you did not see any of a specific office hour call, or if you want to re-see this call, then catch them on BC Office Hours recordings and register on the link that you see here on the page. Thank you so much for joining us. Happy holidays. Enjoy your day and evening. Jagt.